Evening, everyone. Thanks for coming. This is the last talk for the evening, so you guys must be a little bit relieved. Must have been a long day for you. Before we get going, just a quick show of hands. How many of you are currently deploying your applications to Azure? Okay, a few hands. Okay. Now, if you've ever had any failure, whether it's on the cloud or on your local data center, you had an outage, and put your hand up. It doesn't have to be it's planned or unplanned. Your logs getting filled out, whatever it may be. All right? I expect a lot more hands to go up, right? I mean, the only reason that not everyone put their hands up is maybe because some of you are shy. It's okay to have failure in the cloud, or on premises. The other reason could be that you've architected your application really well, and you've not had any failure whatsoever. In that case, I'll come and have a chat with you after the session, all right? Maybe you can pass some tips across to me as well. I want to start with an incident that happened about a year ago. Actually, it's exactly to this day, I think. It was November 18th last year when Microsoft actually rolled out an update to its blob storage. And straight away, the blob storage front end started rejecting new connections. And pretty soon, it was cactus. The blob storage wasn't usable. And with it, it took down a whole bunch of other services. So things like Azure Web Apps, or websites as it was known back then, and Azure VMs, they all went down as well. So you had this cascading effect. Now, a few years ago, I remember that Microsoft, there was a certificate that actually expired on Azure. You guys remember that? Anyone remember that? Yeah? That was a pretty big outage as well. Now, you'd be naive to think that this only happens on Microsoft's infrastructure or whatever. Because Amazon, pretty much soon after the blob storage outage last year, within about 5 or 6 days later, Amazon had an outage on their CloudFront services. And a few years ago, I remember during Christmas, Amazon had a major outage. It's like, that's probably one time that you want all your services to be up. They had a major outage. What I'm trying to say is that, failure is imminent. I mean, particularly when you're looking at the cloud, things can go wrong. And that's what this talk is all about. My name is Mahesh Krishnan. I work as CTO at HealthConnects. It's a Telstra health company. And I've been building Azure applications for a long time now. And the title for today's talk is Architecting Highly Resilient Applications on the Cloud, on Azure. That's the hashtag for if you want to tweet about today, you can use the hashtag ARC427. And that's my Twitter handle as well, Mahesh Krishnan, one word. You can use that. Take pictures and post of it just to boost my vanity, I guess. Anyway, coming back to the topic. Things do go wrong in the cloud. More so than in your local data center itself, which kind of brings the question on why people are deploying to the cloud. There are quite a few reasons. I mean, there are lots and lots of services that come out of the box on Azure that help you, lots and lots of services, so you don't have to write a lot of stuff from scratch. The other reason is that you have this infinite resource at your disposal. So if you want to scale out, you want to add more services and things like that, more instances of your services, you can quite easily do that. But the other factor is that it's also quite cheap. If you want to run a VM, I think an A0 VM on Azure costs about 2 cents an hour or something like that. And it's charged by the minute. So if you're running it for about half an hour, all you end up paying is about 1 cent. That's pretty cheap. So you got to ask this question, like, how come the cost of Azure is cheap? And it boils down to a couple of things. One is they build things on commodity hardware. So this hardware is a lot more inexpensive than the servers that you actually go and put into your own data centers. And the second thing is that it is massively multi-tenanted. So you do have economies of scale. So lots and lots of people are running on the same infrastructure as you are. So you look at it, it's a recipe for things going wrong. You know, people could be vying for the same resources that you are vying for. They'll be trying to get, fighting for the same CPU power and things like that. So how do you go about building an application? So what does it mean? I mean, things can actually go wrong. Does it mean that you can't build applications for high availability? So I'm going to show you how we can actually go about building such an application. So the agenda is roughly as follows. What I want to do first is I want to talk about what we want to achieve. What are the things that we want to address? And then we'll talk about what comes out of the box in Azure that will help you build these resilient applications. And then we'll move on to architecting these applications itself. So I want to talk about how you go about modeling applications. This is the theory part. And then I will talk about building these applications. We'll talk about some of the patterns that you can use in your applications. And then we'll talk about how you go about running these applications and make it resilient as you go along. I also got a demo at the very end. And so what I want to do in this demo is deploy an application across 2 data centers. And I want to simulate failure by pulling the plug on different services. And effectively taking down each and everything in a single data center. And hopefully, the application will still run because I've built it for resilience. Okay? But it's got a lot of moving parts. And it's kind of like a contrived demo. So hopefully, everything goes well. So the first thing we want to ask is, what do we want to achieve? From a business point of view, business probably thinks about 4 different things. One is they want an application that's got high availability. Is the application available all the time, or at least most of the time? So for a lot of people, if the application is not available, for a lot of businesses, it could have financial implications. So you want to make sure that the application is available. The second thing is around disaster recovery. What if something goes wrong? What if your entire data center goes down or your application dies and you need to recover from scratch? Do you have enough things in place? Businesses talk about a couple of factors, things like RPOs and RTOs. RTO stands for Restore Time Objective, like how quickly can you get your application up and running again. And Restore Point Objective is to what point you can actually get the application running. I mean, how much of a data loss can you actually tolerate? Is it 5 seconds? Is it 10 seconds? Those are things that you need to be asking the business. And things can go wrong. I mean, I remember it was a couple of years ago in Brisbane when we had the floods in the CBD, right? You guys should probably remember that more than, because I'm assuming that a lot of people are from Queensland, right? And there were a whole bunch of data centers that were there in the basement of buildings in CBD. Guess what happened? They all went down. And those are situations that you don't want to happen at all. But if it does happen, how do you recover from it? What about responsiveness? Response is not all about how quickly your application reacts to user input or for a process when it actually calls that service. How quickly does it react? If it takes 2 minutes to send back a response, does it mean it's available? Right? So you need to start capturing about responsiveness is an important thing as well. And we want to talk about performance. A lot of people confuse performance and responsiveness. Performance is how quickly you can actually do something. Responsiveness is how quickly you can respond to someone. So you can actually respond straight away and saying, hey, someone asks you to do something, you can quickly say, yes, I can do it, and you can be on your merry way. But sometimes it'll take a lot of time to do the actual action. So now that we've got all these things, what do we have out of the box on Azure to help you build a responsive application? So I'll tie a lot of these things in later with some of the patterns and the theory and all that. So a lot of things comes out of the box to help you build a resilient application. First and foremost, you want to eliminate all single points of failure. So on Azure, you can run multiple instances of a service. So if you've got a VM, you can run multiple instances of it. If you've got web apps, you can run multiple web apps as well. So what happens is you should at least be running 2 instances. So even if one of them goes down, the other one is still there to give you that high availability. And Microsoft will be doing it all the time. They'll be applying patches on your servers and things like that. So you need at least 2 to make sure that there is you have continuous availability. What happens when there's high load and the server can't handle it anymore? This is where auto-scaling comes into play. So you have this elasticity on demand, or the ability to scale out and scale back in when the demand goes away. That comes out of the box as well. You have storage redundancy. So we spoke about running multiple instances of a server or a service. What about storage? For something like Azure storage, each and table storage, blobs, and queues are stored 3 times over in the same data center. So even if one of them actually goes down, the primary dies down, maybe because hardware failure, there are 2 other instances over there, 2 other copies of the data that's available that you can actually leverage off. And you also have this geo-redundancy. So what if the entire data center goes down? You'll be able to have 3 additional copies of this copied across to another data center in the same, so that you can switch to it if something goes wrong. You also have database replication. Database replication is very similar to the storage redundancy, except it uses a different technology. And this is for SQL database. So when you have SQL database running, you can have a primary and you can have multiple secondaries where the data is replicated across. So if something actually goes wrong, you'll be able to get the data out of these secondaries. You have things like Traffic Manager for location transparency. So when I run multiple web apps, I can have a traffic manager sitting on top. I can redirect the traffic accordingly. And if one of those web apps goes down, it can redirect it to the other web app. There's a whole bunch of automation and scripting infrastructure that's there in place. Yes, Azure provides you with a nice portal. You can go in and configure things. You can load your application. You can press a slider to scale up and down and do all those nice things. But you don't want someone to be going about doing these things. You want everything to be scripted. That's one of the key things about doing automatic deployment and things like that. So Azure exposes a whole bunch of services as RESTful API, and then it provides a whole bunch of PowerShell scripts that allow you to configure this and run it. It also provides a whole bunch of diagnostics and telemetry information, things like App Insight that you can actually use. Now, it provides all these things, right? But it's up to you as an architect and a developer to make use of these things to build a really resilient application. And we'll see how we do it. As I said, I've broken down the talk into 3 parts. One in architecting for resilience. I've broken it down in how you go about modeling the application, how you go about building it, and how you go about running this application. So let's talk about modeling the application itself. As a developer, if someone actually comes and gives you a set of requirements, your first instinct is to effectively go in and start cutting code, right? But if you start wearing your architect hat on, you take a step back and start thinking about the non-functional requirements that I spoke about. And start thinking about how you model your application for things like availability and DR and things like that. So there are 4 things that I want to talk about in modeling the application. The first and foremost is workload modeling. Now, workload modeling is all about decomposing your application based on the workload of your application. Now, there's a lot of words out there, and I want to give an example to explain how it actually works. Let's take an example of a shopping, online shopping experience. You can at least, it has many distinct workloads, but there are actually 2 that stand out. One is the fact that people can go in and browse a catalog, find an item, and they may be able to search it and look it up. That's one workload. The second workload is all about the buying experience, where you add it to a cart, you go in and check out and pay for it through your credit card and so on. Now, in terms of requirements, they both have different requirements from a business point of view, different criticality to the business. They have different ways it works. For example, from a security perspective or from an authentication perspective, to actually search the catalog and look for an item, you probably don't want the user to be authenticated. Whereas when you're going over to buy, you may say, hey, you know what, I want this person to have logged in using a username and password so they can actually buy things and so on. And in terms of importance to business, where availability and things like that may vary depending on the workload itself. So the way you go about doing it is you split the application based on your bounded context, its boundaries, and effectively what you want to do is each and every workload should be autonomous by itself. so you can actually scale it independently. So I've got this thing where you divide first and multiply. So you divide this application first, and then you can actually multiply to scale it as well. You also want to start thinking about the load life cycle of the application. Now, each and every application has a different load life cycle. So for the shopping cart experience, you may experience a lot of load during evening times when people go home and they're trying to do some shopping. Or if you look at the Black Friday sale in the US, which happens, I think sometime this year, in a couple of weeks, that's probably the most important day in the retail calendar for people. You know that there's going to be a lot of traffic happening on that day, and you want high availability during the day. So you know how the traffic is going to be, and you want to model all these things based on your workload. Now I've got an example of a sporting website to actually give you an example of how the modeling of the workload load lifecycle looks like. It's got a couple of distinctive workloads. Now, if you haven't figured out, I'm basically from India, and like most Indians, I kind of sucker for cricket, I guess. So I took an example from Cricinfo, and Warner's been in the news lately, and you want to look at player profiles and the statistics and things like that, and that's kind of like one workload. So you go and look at matches that have gone, look at score, statistics and information of players, their profiles, and so on. And then you have another distinct workload, which I call the live workload. When a match is going on, and you want to see the scores and what's happening, you want to get ball-by-ball commentary and things like that, you can go in and have a look at it. They have two distinctive workloads, and then their load life cycle also changes. So if you think about it, right, in the statistics workload, the information is fairly static in nature. It doesn't change much. Well, it does change, but it doesn't change every minute. Whereas on the live score workload, it actually changes all the time. But then it only changes when a match is going on. And in terms of importance, if there is a temporary failure, you have like a major impact when the game is going on. People will, you'll have a big hue and cry when you go to the site and it's down when a match is going on. People don't like it that much. Whereas for a statistics workload, you go look up the profile of Dave Warner, and it's not there. It's no big deal for a lot of people. If the website is down, or if the data is not available, let's say the database that actually holds the information about the player statistics is down, you can actually go and show some kind of cached information. So you have graceful degradation, and you show old stale data. And for a lot of people, that's okay. But you can't do something like that with a live workload. And similarly, variations in load is pretty important. When a match is going on, you have major spikes on the live workload itself. So a lot of people are trying to get in and look at the scores. Whereas on the statistics workload, it pretty much remains stable throughout the entire year. So when you're actually modeling it, you need to take all these things into consideration. And what I'm going to argue is that when you are looking at modeling availability, these two things play a very important part. Now, modeling, whenever people talk about availability, they talk about SLAs, service level agreements, and they talk in terms of nines, right? So if you got 1 9, which is 90, the downtime per year is about 36.5 days. That's a lot. As the number of nines increases, the downtime actually decreases as well. So you actually look at this, if you've got 4 nines, that's about 52 minutes of downtime in a year. That's about 4 minutes in a month. Can anyone guess what the downtime would be for 5 nines over there? 99.999? 5 nines? It's about 5.2 minutes in a year. Minutes. So that's about 7 seconds in a week.
1 second a day.
That's it, right? So the time that I counted, that was your downtime. That's all you could actually afford this week, right? Think about that. So it's one thing to actually basically say, hey, you know what? My application has got to be up all the time. There's going to be loss of data and so on. I want like 5 nines and so on. but the cost of the application will actually increase, and the complexity of the application will increase as the number of nines go up. But I'm going to turn it around and say, hey, because you've actually split your applications into these workloads and you've modeled the availability, the load lifecycle of the workload, if we go back to the Cricut website, we can actually say, hey, you know what? I'm going to provide maybe 4 nines or even 5 nines of availability when a match is actually going on. But during other times, I can fall back to 99% availability. That allows you to that gives you a bit more flexibility in terms of how we can actually manage things like cost and so on. The other thing that you need to model is around failure. Now, failure is imminent, all right? So you can avoid failure as much as you can, but I think your strategy should be to be around embracing failure. Sure, you should try and avoid failure as much as you can, but the key thing over here is to embrace failure. So you basically say, hey, failure is going to happen. I'm going to put some things in place to handle this failure. But first, what you need to do is identify and analyze all the failures that can potentially happen in your system and their effects on it. So, for example, there are about 4 sets of failures that I've actually noted. One is around capability. What happens when there is some mistake in the application itself, application logic, then that fails? What happens when the transaction actually fails? How are you going to handle it? Things like connectivity. What if the database is down? What are you going to do? Is the application going to stop working? What if you have a service that you talk to and you have no control over, and that service is not available? Does it mean your application stops working as well? Or how do you handle it when there's something like that happens? What about capacity? How many times has the log file filled up your server and your application is now down because of that? So what happens when storage fills up? What if the network is down? What if you make some changes in the configuration and that completely brings down your application? So you got to start thinking about effectively modeling all the failures and how you're going to handle these things. Once you've done all these things, it's time to start building your application itself. And this is where I want to talk about 3 specific sets of, I call it the 3 R's. You got to start looking at patterns for resiliency, redundancy, and recovery. Let's start with the first one. We'll talk about resiliency pattern itself. The first thing that you need to do is asynchrony, async everything. I'm not just talking about putting async await in your application. Well, you still do that, but it's much more than that, right? An example over here is a queue-centric workflow. So what you do in the queue-centric workflow is rather than write directly to a database, you write to a queue. And so what happens is there's a command handlers that are there. They pick these items from the queue, and then they write it across to the database. Everything happens asynchronously. So the application so let's assume that the database operation is pretty slow. You don't have to wait around for the database to actually finish writing as many updates and inserts as you want. You basically put everything in a queue, send it across to the queue and say, hey, just do this operation. And then the application goes away straight away. Now, humans do this all the time, right? So for example, let's take the example of, I want to apply for a permit, and I go to the council. Let's say I want to chop down a tree in my house. I go to the council with the permit, or application for a permit, go to the council, and there's a window open over there, and I go submit the form. Let's assume that you wait there till he actually processes the form, right? It can take 5 minutes, 10 minutes. You're completely blocked. You're not able to do anything else. Not only that, there are other people who are queuing up behind you, waiting for their turn to submit the form. Let's imagine it's a little bit more complicated. It's not chopping down a tree. It's like a building permit, and it may take a lot of time to actually process this. Are you going to be sitting around waiting at the counter for about several hours before that gets processed? No, you don't, right? You effectively go leave the form somewhere, drop it in a box, and then you go do whatever you want to do. Now, there are people in the council who will actually pick these things up and process these forms, and when it's done, they notify you. That's exactly how queue-centric workflow works. So you drop an item into the queue, and the application goes in its merry way. It's not waiting around not doing anything. It doesn't block anything. It goes away. And then the command handler over here picks these items from the queue and then starts processing them. Now imagine the scenario where there's a lot of things piled up in a council. They may get other people to work through the pile of application forms, right? The same thing happens over here. If there's a lot of items in the queue, you can spin up more instances over here of the command handler to process all of those things. Now you do lose something in the process, and that is if you made a request to update an item, and insert an item or update an item, it takes a while before that actually happens, and the thing flows across to the database itself. So there's a bit of a lag. There's not immediate consistency. So this is called eventual consistency. And by actually introducing eventual consistency, you get you have a much more resilient application. So what this actually does is it completely decouples the application. And each and every one of these components are decoupled and are not dependent on the other thing to be running for the whole application to work. For example, if the command handler is not working, it's okay, you still keep putting items into the queue, and when the command handler is back again, it'll start picking these things up and writing to the database. If the database is down, that's not a problem, because this actually waits, and there are still items in the queue that needs to be processed. When it's up again, it can start writing items to the queue. Sorry, items to the database. There are a whole bunch of patterns that you have for handling errors itself. The first one is to try and try again. So what happens when you, right now, is when you make a phone call. Let's assume you're making a phone call to someone, and they're not picking up the phone. The first thing is you have a timeout, right? So you don't wait forever, and the phone keeps ringing for 5 minutes or 10 minutes, you just don't hold the phone, right? There's a timeout. At some point in time, you give up, okay? So that's something that you need to introduce in your application, the concept of timeout. The second thing is that you call, and it's not picking up the phone, you hang up, and what do you immediately do? Most people would call again. Hey, maybe they didn't hear the phone the first time, or they couldn't get it on time. I'm going to call again and see if they're there. The same thing applies over here. At first time you try and call a service, maybe the service is busy or something like that. You call again, you try again, and maybe this time it works. What if you try again and it doesn't work, right? You don't keep trying over and over again. Well, if you call someone, what you would normally do is you wait for a while before you try and calling this person again, right? You do the same thing. You have what is known as an exponential back-off. So you try a couple of times, and then the service is in there, you back off, and you wait for a while before you call again. And you double this time every time. Let's say, just going back to this phone example, right? Let's assume that the fault is not with the person, or the person. Let's assume the cell tower itself is broken, or for some reason there's kind of like a transient error on the cell tower, and it's not actually working at this point in time. If everyone keeps trying at the same time, trying to do the retry over and over again, the tower may actually come up, and then it'll fall over in a big heap because like everyone is bombarding the server with these calls, right? By doing these, the timeout, like exponential back off and things like that, you introduce a bit of randomness into the system so that not everyone is hitting the cell tower or the application service at the same time. So all that is really important in terms of retry. The second way of handling failure is to ignore it. I know some of you are actually thinking, great, I can put an empty try-catch block. And that's not what I mean, okay? What I mean is that there may be a genuine business reason for ignoring the failure. Let's say I've got a shopping cart, and people pay with some kind of a store credit, and everyone's got a different store credit limit. Let's say I've got $100, right, and I'm trying to buy a book. It's probably $25. I go into the service to see if I fall within that credit limit. Let's assume that service is actually down. Are you going to deny this person, deny me of buying the book because that service is down? So you take a calculated risk, calculated fund, and saying, you know what, that service is actually down, so I'm going to take a little bit of business risk, and I'm going to ignore that failure, and I'm going to sell him this book anyway. The third thing is to actually fake it, okay? So you basically act as if everything was okay, and then you send him some data back. Well, you don't send any data back. So if you've got some cache data, that's what you send. Giving that example of Dave Warner's statistics, you go look it up. The data is not available right now because the database is down, but you have some kind of cache data. Send them the cache data. Nobody's actually going to know. That's better than actually throwing up an error. So that may actually work for a lot of, in a lot of situations. You can also deny the request. That's almost like a last resort, I think. Nothing else happens, maybe it's important that we actually let the user know, hey, something's actually gone wrong. Sorry, I can't process your request. But before that, I want you to think about going over to plan B. And going over to plan B is effectively maybe going over to some kind of a graceful degradation. Let's assume that you're writing to a fast server, but that's not, that is broken. You write to the temporary file. You can do anything that you want, right? So I want to explain that with another pattern, which is actually called a circuit breaker. Circuit breaker, I mean, we all know how a circuit breaker actually works. So effectively, if you try and hit a server or in a service, let's say the electricity is down. I mean, let's say there's too much power or something going through. The system actually trips so that no damage actually happens, right? Rather than explain it, I want to give a completely different example, analogy, I should say, to explain this, right? Let's assume that traffic is flowing through the main road, and there's something wrong gone on the main road. So what you do with this plan B is to actually send them through a detour, through a side street. So plan A is closed. Let's assume that is closed. You actually let people in through plan B, which is a side street. Now, every now and then, you've got to start sending people through the main road to ensure that, hey, maybe the problem is actually fixed. We'll have to send them through the main road to ensure that once that road is back again, we can send everyone through. So you've got this half-open state where you route some traffic over through plan A or the main road and some traffic through to plan B. If that actually fails, you can continue to send people through to the side street. But what I'm going to argue here is, why do we need to do this only when things go wrong? What if we did it all the time, right? So we send most people through the main road. Every now and then we route some people over through the side street. That way what actually happens is you ensure that the side street is also working all the time. And Amazon does it all the time. They have this thing called, sorry, not Amazon, Netflix does it all the time. They run a lot of infrastructure on Amazon, and they have this concept of Chaos Monkey. What Chaos Monkey does is it goes into the main road and effectively blocks it. And then you have no option but you send some traffic through to the side street. That way, you ensure that even when disaster actually occurs, you are covered. And you don't find out when main road is actually blocked and send someone through the side street, and that is blocked as well. And so your plan B has failed as well. I want to talk about redundancy patterns. I did say earlier that you want to eliminate all single points of failure. This is what you do by introducing redundancy into the system. So you run multiple instances of your service or servers in the system. So even if one of them actually goes down, the second one will be available. And you do this just not for your services, you do this for your data and things like that as well. But it only addresses certain, what if the entire data center goes down? It doesn't cover that, right? So you've got multiple instances sitting in the same data center, and you have a flood, or you have, there was a fire breaks out in your data center. It happened in Microsoft. Microsoft actually runs a data center in China through a partner in Shanghai. There was a fire that actually broke down, and effectively, it took several hours to put the fire down, and then they had to clean up stuff in the data center before the engineers could go in and have a look at what damage was done. So things like that could happen. So what happens when your entire data center goes down? That's where you got to start thinking about introducing multiple redundancies across multiple data centers. And Azure does this quite well. I mean, like, you have different regions. You have one in Melbourne and you have one in Sydney, and you can set it up in such a way that if Melbourne goes down, you can have Sydney take over. What if there's something wrong in Azure itself, right, and something goes wrong, certificate error or something like that, right? Something dramatic happens and it's not available. So you got to start thinking about maybe having multiple redundancies across multiple providers. You can have Azure, and you can have some of these redundancies. If something actually fails, you can actually have it fail over to your on-premises system if you want, or to Amazon if you like. So now if you look at it, right, for each and every one of these things, the cost and the complexity goes up. So with just multiple copies in the same DC, yeah, there's a bit of cost to it. Rather than having everything like a single service or a single server, the cost literally doubles. If you have it over here, again, the cost goes up. And the complexity goes up as well. And if you start thinking about of having multiple redundancies across multiple providers, the cost goes up dramatically as well, and the complexity goes up. But the business it may be perfectly okay for the business. If you've got a big banking application or whatever it may be that loses money if the service is down, then it's perfectly okay to spend on this added complexity and added the cost as well. So I want to talk about recovery patterns. Let's assume that something has actually gone wrong. How do you recover from it? First and foremost, backup and restore. And yes, you got to back up your database, and if something goes wrong, you restore it. But when I talk about backup and restore, I want you to think about a much more fine-grained level, right? Maybe when you're inserting items to the database or you're inserting stuff to the data to a data store, you store intermediate states, and then you restore it from those intermediate states as well. You can also use compensators. Now, this is done really well in relational databases, right? I mean, everything you can run it in a transaction, and you do multiple inserts and so on, and then when something goes wrong, you roll back, which effectively restores the state it was in before. But what it does is it locks up things. And if you lock up tables and rows and columns and things like that for a long time, that slows down, it affects your performance. Now, so rather than do that, maybe you can actually start thinking about compensators. What I mean by compensators is that rather than put everything in a transaction, let's say you write something. Let's say we take money from one account and put it in another account. Or a much better example would be depositing a check in the bank. What the bank actually does is as soon as you deposit a check in the bank, it's $500, they credit to you that amount. Let's assume the check actually bounced. They don't lock the entire thing in a transaction and wait for the check to be processed. The credit will be applied straight away, and then when the check actually bounces, they have a compensating transaction that actually says, well, the check has actually bounced, and they'll debit the $500 from the account. So I want you to think about how you can actually implement things like that in your own application. That way you don't have to worry about transactions and things like that. Is it complex? Yes, it is. But it allows you to, it allows you that added flexibility of not locking tables and things like that. Now, there are certain systems that actually work really well with something like this. Event stores are really good because with event stores, what you do is you send events across to your data store. You say, hey, this item has been added, this item has been deleted, you've done this, and you do a whole bunch of things, send these as events, and then when you play back all these events, it restores the state of the data in the way that you actually want. So event stores are really great for this. You also need to think about item potency. Now, what I mean by item potency is that, let's say you actually go and update delete a record or whatever it may be, right? Now, I've gone and said, hey, go ahead and delete this record. And then I come back again, but something has gone wrong. There was some kind of network error or something like that. I never got notification whether it was deleted or not. So I want to retry, and so I do this operation again. So does it throw up an error? I mean, think of a situation where you're trying to deduct money from a certain account, right? And if it's your account, you start worrying about it. So first time you've gone and said, hey, debit $500 from my account. oh, I wasn't sure whether it actually did it or not. Oh, let me just try it again. Maybe it was successful the first time, you just didn't know it. You didn't want that operation to have been done twice. This is where idempotency comes into play. If you do the same action twice, you end up with exactly the same result. You don't subtract $500 from the account more than once. So you need to start thinking about that. Now that you've kind of like built up your application, we've got to start thinking about how you go about what are the things that you need to do when you're running the application. And there are three things that I want to talk about. First is automate all the things. I spoke about the scripting infrastructure earlier, right? The portal is great, okay? But you don't want to be doing all the things in the portal. You don't want to be deploying your application in the portal. I think there's a phrase or a quote in the Matrix. It goes something like, "Don't send a human to do a computer's job," or something like that. I can't remember the exact quote, but that kind of rings a bell to me, right? Just like you shouldn't let a human go and deploy your application into production by following a series of steps. You should script it all the time. That's where all this continuous integration and continuous delivery and all that comes into play. And Azure provides all the infrastructure and the scripting infrastructure and the PowerShell scripts and everything for you to do it. So automate everything. While the application is running, you've got to start measuring everything as well. There's a lot of telemetry information available. Start collecting all the telemetry information. But it's not enough if you just collect this information if you don't do anything with it. So you've got to monitor it as well. So there are things like app insights that'll allow you to collect telemetry information and so on. But you've got to actively monitor it and make sure that you do things with that information that you collect. So I want to talk about a sample implementation that I have. So I've written a very, very simple application. And what I've done with this application is I've deployed it to 2 data centers. So let's DC1. Let's make DC1 as a primary data center. This isn't working. Okay, cool. So let's take that as a primary data center, and then there's a secondary data center as well. So the primary data center. The primary data center is actually nothing more than an ASP.NET web application, and it's got web jobs running over there as well. So every time it's a very simple application. All it does is update contact information. So I've got a primary database over here, and this data center reads the data from this database over here. When it wants to write, it doesn't write directly. This is where I was talking about this queue-centric workflow, right? So it posts an item into an Azure queue. And when it posts this item, there's a command handler, the web job actually, picks it up and then writes it to the primary database. It's pretty simple enough, right? But then because I want redundancy, I've deployed the same thing across into the secondary data center over here. The secondary data center exactly has the same thing. Yes? Question?
What happens if the second transaction that you have to do after that depends on the output of the first one?
Yeah, see, this is why I actually said that you've got to make sure that you model your application in such a way that you take that eventual consistency into consideration. So is it hard? Yes, it is, right? But by actually catering for that, you kind of like decouple your application, components in your application itself. So going back to this example, I've got the secondary data center over here where it's exactly the same thing, right? The reads come out of this secondary database over here. This database is actually replicated. There's a live replication that actually goes on where every time someone actually writes into the SQL database, that writes actually goes across to the secondary database. You cannot write to the secondary database, but you can read out of it, okay? So let's assume that I hit the secondary server. I put an item into the queue. It actually writes across to the primary database. So the writes will be a little bit slower because of network latency and things like that. That's perfectly fine, right? But the reads will be very quick because you're reading out of the read-only copy, which is sitting in the same data center. Every time it actually goes across to another data center, it's going to be a little bit of slow because of network latency and things like that. Okay. Now, I have an Azure Traffic Manager over here, and what it does is every time someone actually makes a request, it routes all the traffic across to the primary data center. If the primary center goes down, it'll route the traffic across to the secondary data center. Now, notice that I've got these dotted lines running over here as well. Now, if for some reason the queue goes down over here, let's say the primary queue goes down, or the secondary queue goes down. So what happens is, this is the thing where I actually spoke about circuit breaker and plan B and so on. It looks at it and goes like, hey, it's not working. I'm going to, instead of waiting or throwing back an error, I'm going to write to the secondary queue. So we have some kind of a graceful degradation. So the write is a little bit slow this time, but it still goes through. That's your plan B. So your plan B is, this doesn't work, I'm going to write to this one. So now it's a bit more, it's a little bit slower, but at least the application is still working. If this database actually goes down altogether, what should happen is all the writes should start going over to this database over here. And that becomes the primary database. So effectively, you've got redundancy in multiple places, and so it should actually work. So I'm going to switch over and show you how this is actually written. So the traffic manager, it's a really good question. So the question is, what happens when the traffic manager actually goes down? You can think, or look at the traffic manager and goes like, hey, there's a single point of failure, right? But it's much bigger. It's almost like a DNS resolver, right? So they have multiple redundancies built into it, and it's a global one as well. So it shouldn't happen in theory. Yeah. So let me switch over to my machine. So I've got my Azure portal running over here. Now, I've got two web apps, Ignite AU, and that's my primary web app. And notice that it's actually deployed to West US. Can you guys see it from there? It's deployed to West US, okay? If I click on this, it's going to go to igniteau.azurewebsites.net, which is what I've got over here, okay? It's a pretty simple application. What it does is I can go look at customer contacts, and it goes over to the database and lists all, bunch of contact information that's actually stored over there. I've also got Ignite AU secondary, and this is actually deployed in the East US. Okay? And that's the secondary website. Now, on purpose, I actually changed the background color on it to red, and I put in the secondary website over there, just so that you can actually distinguish between, when we go to which site, okay, more than anything else. But in theory, when you're deploying to site A and DC1 and DC2, they will look exactly the same. I've also got a traffic manager over here, which is timed out. So what the traffic manager does is I've got both these websites on it. The traffic manager allows you to route traffic based on a few policies. You can do round robin, which means that first, when you hit the traffic manager, it'll route all the traffic to site A or DC1, and then the next one will be DC2, and then the third one will be DC1, and so on and so forth, right? Or you can basically set it up to failover. That's one of the load balancing methods, which means that I pick which one all the traffic should be routed to, and if something actually goes wrong, then I'll route everything across to the secondary one. So I've got these endpoints configured over here. Those are the two endpoints, Ignite AU AzureWebsites.net and Ignite AU secondary AzureWebsites.net. And if I go into configure over here, $0 available. So notice that I've got this failover priority list. So it goes to the West US first, which is my primary, and if that actually fails, it goes over to the secondary over here. Now, let me go and click this. Sorry. I thought it was a link over there. It's all right. So whenever I hit, so rather than actually go over to the actual website, you use the traffic manager's URL at the top over there, and that will direct the traffic accordingly. Okay. Now, if I go back to my application itself, it's not it. It's a very simple application. I've got a website over here. I'm not going to run through the entire application, but I'm going to show you, open up the web config file, so I can show you a couple of things in there. The web config file has a default connection, which is effectively the site that the database that it actually connects to. And similarly, it's also got a connection over here for the storage. It's got the default storage and the secondary storage as well. So if the default storage is actually not working, the plan B is to go to the secondary storage. The same thing with over here. That's the default connection and the secondary connection. Now I've got something called a command connection. So when I do my writes, I've got to write to the primary database. I have no other choice. So I can't write it to the secondary database because it's read-only, right? So that's a unique connection string. Okay. So let's go in over here, and let me go over to customer contacts. And if I go in and, let's say, add a new item. Let's go. Bill Gates is probably not in my list. So it's actually, now what's happened is it's actually submitted the item to the queue, and you notice that it doesn't show up straight away. If I go over to my Azure Management Studio, and if I'm quick enough, yeah. So that's actually probably processed it pretty quickly. There you go. So it's inserted Bill Gates over there, right? Notice that there's a bit of a lag. The lag was because I put it to the queue, and then the queue processed it, and then it sent it across. So usually it's pretty good. If you increase the number of queues that are actually processing it, and you have large enough servers set up, so a lot of these things will happen pretty quickly. So even it'll be able to handle lots and lots of items in the queues pretty quickly. Now, if I go to my secondary server, if I go to my contacts list over here, this is the replication in place. So the data has actually flown through to the copy of the database as well. Now, I just want to quickly jump into the portal. I want to show you now. Replication is extremely easy to set up on SQL database. So, and it's almost like click a couple of buttons, and replication is set up, ready to go. And see, notice that this actually shows the replication that's there between the east and west coast. Okay, so typically the latency is under 5 seconds. So if something goes wrong in your primary data center, and everything went pear-shaped, then the maximum amount of data loss that you could potentially have is about 5 seconds worth. Yeah, well, yeah, it's pretty much, yeah, it is pretty much the same for most of the centers. Yeah, it's up to 5 seconds. Usually, sometimes it's much quicker than that. So, let's decide what shall we take down first. Maybe we'll go and delete the database, right? This is my primary database. I can go ahead and deleted. Now, this is where I got to start my prayers to the demo gods and help make sure everything's okay. So when I hit that, right, so I actually deleted the primary database altogether. If I go back to my website over here, and let's say if I reload. If I go in and edit Bill Gates, notice one of the things that I actually did was I said send update request rather than update straight away, just to give the user the idea that, hey, it's not happening straight away, but you're actually sending a request instead of doing it. So I sent this, this request, but one of the things that if you actually notice is that the database is still running, right? This is the primary database, and it should go over to the database that we actually deleted, right? My insert went through, well, the request went through, but the reads are still coming back to me. That's because it's now gone over to plan B and it shows everything from the secondary database. Now, what I need to do next is, of course, I need to go ahead and, yes? Question?
Is secondary still the secondary, or did it get promoted to primary?
Yeah, it's a really good question. So what happens, right, when the database actually goes down, and if there are only two it gets promoted to being a primary. So I should be able to write to it, and it should work, okay? But the system doesn't know that. It still thinks that the primary is TechEd AU. No, it will not. So you got to set up replicate. Well, yeah, so it won't. So the secondary is actually taken over. So you'll be doing lots of updates to that. So that's how it'll work. So the second thing I want to do is now go ahead and delete Ignite AU as well. I mean, I could stop it, right? But there's no thrill in that. Let's go and delete the whole thing. Now, that's all right. So it's deleting it. Now, what happens is, once you actually deleted it, right, the traffic manager takes over and it looks at the site and says, hey, this site is now down. And remember that we actually set it up over here. And notice if you go to the endpoints, the first one has actually completely disappeared. It's gone, it's deleted, right? So now it says, hey, hang on a second, that's no longer there, so I'm going to start routing all my traffic across to the secondary site. So there's usually a little bit of a lag for the DNS to propagate, but maybe 30 seconds is more than enough. So let's just go ahead and hit that. I need to go to the traffic. That's the traffic manager site. So if I go over and do a refresh over here, notice that it actually flipped over to secondary, right? Now, what about writing to the database? So now, ideally, like I said, you need to script everything. So you can automate this thing by actually looking at it and saying, hey, it's been out for a while. How do I handle this thing? And you can automatically switch over from the database connection string from the primary to the secondary and make it the primary now. But in this case, because if this kicks on too quickly, then I won't have much of a demo. I kind of have to do it manually. So the first thing, one of the things I want to show you is if I go in and look at the request that I sent to update Bill Gates, right? That didn't work. I mean, it usually goes into the queue, and then the web job actually keeps trying it for a certain amount of time before it actually gives up. So that should either be in the poison queue. It's not here. So it's still, there you go. It's actually gone into the poison queue now. So it tries it for a certain amount of time, and then it gives up. Right? You can actually set this thing up saying, hey, how long do you want to try it, and whether how you want to process it when things don't work. So it's been trying to write to the primary database, and the primary database doesn't exist. And so after a few attempts, this is the thing with the timeout is actually important. You actually give up and say, hey, well, it's not working. I'm going to give up now. I'm going to throw it into a poison queue so that later on you can come up with some other way of processing that. So what I'm going to do real quick is I'm going to go ahead and change the connection string on the command for the web job, and I'm going to quickly upload this thing. So the command should actually be going to TechEd AU2, and let me just publish this web job. So ideally, you can actually also go and change it in your configuration settings on the portal, but I thought this was a little bit quicker to do. I think it's deployed. Yep, failed due to build errors. All right. Let's try it one more time. Let's do a rebuild. Yeah, the profile is right. It's all good. It is deploying to the secondary. Let's do it one more time. One update. It says build errors, but I don't see any build errors. It's a bit odd. There you go. This is exactly why you need to have it scripted, I think. It'll be interesting to see if it actually updated it, although it says failed. I'm going to try it one more time to actually update this custom database. Let's go in and edit this. So that's the message that's actually popped over here. Now see this DQ count over here? This is what happens when you actually go in and it DQs the message. It loads the message, and then it tries to write it to the database, and if it actually fails, it increases the DQ count. So if the DQ count comes up to a certain number, it decides to give up. So I'm not sure why this actually failed. It's a bit bizarre. Never had this one before. I don't know what it is. There are no errors. Close all documents. Let's do this rebuild one more time. And publish one last time. Yeah. Sorry?
It's coming up with messages saying build failed and rebuild all failed.
Where are you seeing that? Oh, this build failed. All right. Let's try one more time. Rebuild all failed. What? That's a bit odd. So maybe I should open up Visual Studio, close and open it up again, right? This is what we normally do. We'll give it one more chance, one more try, right? Try, retry, and then give up after a few attempts. Okay, that looked all right. Yeah. Okay, just don't ask, okay? Okay, let's try this one more time. Let's just go. I'm assuming that this failed again, so let's go and refresh this. And see that it's actually put it in the poison queue. So let's go ahead and update Bill Gates one more time. So ideally what you would do is, like, now that the system is up again, you can have some script that picks up the messages from the poison queue and then puts it up in the main queue so you can actually reprocess them. So you can do things like that. All right. I've updated it. If I go back over here and look up peak message, it hasn't picked it up yet because the DQ count is still 0. It's not going very well, is it? Let's try deploying it one more time. Publishers of Azure Web Jobs. That's the right site. Let's make sure the app config is right as well. I'm looking in TechEd AU, which is the storage account for the second one. It's all good. And let's just publish this one more time. Okay. Sorry? Configured for what?
In your configuration just previously, you were using the fallback settings, not the failback settings.
Yeah, this is the secondary server. So it's actually looking in TechEd AU2. That is a storage account for the secondary server, and the command is TechEd AU from the database as well. So that's good. What the hell? You know what? I'm going to run this from here. Just run the kube processor locally, right? Just so that we can actually finish the demo. And let's see if it actually worked. Let's have another look, see what I missed. So hopefully it's not picking it up from here. Okay, I think it's time to give up, right? Anyway, so let me switch back to my slides. So that was the demo that didn't quite finish at the very end. But there are a few key takeaways for you over here. First thing I want to tell you is one of the key messages I want to say is, you don't have to avoid failure, right? Think about embracing failure. If there's one message that I want to get out of this talk, that's it. And that's the one thing. The second thing is, I want you to, when you start your application, I want to start thinking about how you model your application for, around your workload, the load lifecycle of the application, and also around availability. And the third thing is, we spoke about a bunch of patterns. Primarily, I want you to think about patterns for, we spoke about the 3 R's, resilience, redundancy, and recovery. And we talked about a whole bunch of patterns, things around asynchrony, timeouts, how you go about doing retries. We spoke about circuit breakers and how you set up replication across different DCs and things like that as well. And the last message I wanted to talk about was, automate, monitor, and measure all the time. And that didn't start up. So if you got any questions, you can ask the questions. Don't forget to fill out your evals and make sure you give me a good rating in spite of the failed demo at the very end. Yes, question.
My question is, now that from my memory, the circuit breaker has been already implemented on the Azure side. Am I correct?
So there are a number of things that are, so the question is the circuit breaker pattern is implemented on Azure. So there are a number of things that are implemented on Azure, things like the retry and so on and so forth. I mean, depending on the libraries that you actually use, they're all implemented. So you do have things like timeout. Circuit breaker itself is not implemented. I mean, it depends on how you decide which is plan A and plan B. Yeah. Any other question? Yes?
You
Yeah?
So that sounds fine. Like you talked about them obviously using their secondary route to the application.
Yeah.
What about further down when you're saying, like for example, where you had your scenario got DC1, DC2, always writing to your primary database.
Mm-hmm.
Do you ever want to trial going the other way to your secondary database?
Yeah, I think, there are certain things that it's hard to fail over, right? So you can basically say, well, I'm going to completely get rid of the primary database and make sure everything goes over to the secondary. It's hard, right? Sometimes you don't want to lose any data whatsoever, even if it's 5 seconds worth in a production system. Yes, definitely from testing environment, you should do that. But on a live site, I would be a little bit reluctant to do it. I mean, yeah, things that actually don't cause, damage to your data or whatever it is, sure, go ahead and try some of those things. Yeah. Any other question? Yeah.
Usually users, when they're on the website, they go and fill out a form, click add. They want to see it there and then updated, and there's
Yep.
this delay.
Oh, yeah, so the question is, well, sometimes users go in and update something in the site, and if the data is not updated straight away, what happens? So effectively, we use a cache for some of that stuff. So you can actually put that information in the cache, and so when the primary goes to get the data back, it picks it up of a cache, and that solves that problem. Yeah. Any questions? All right, if you don't know the questions, we'll call it a wrap. Thanks, guys.